Hello everyone, welcome to IIT and Gate classes. This is the lecture 5 on TOC. Okay, we are in chapter 2 of TOC and I have already discussed 4 topics of this chapter, and the 5th topic of this chapter is NFA with null move. Okay, so the sequence which I am going to follow for the chapter 2 is given by the syllabus of this chapter, and I have discussed the syllabus of this chapter in second video itself. Okay, so please watch that video. From that video you will get the clarity about how I am going to cover this chapter 2, that is finite automata and regular languages. Okay, so let me start NFA with null move. Okay, so this is a very simple case of NFA in which null moves are allowed. Okay, as the name suggests, here null moves are also allowed. This is an example of null move. Okay, so what exactly this means, let me tell you briefly. Okay, so let us take NFA in which initial state Q0, after reading A we move to Q1. Okay, so let's take example of a string. Okay, so we have a string double A. Okay, and after double A we can have any number of A's, B's and so on. It hardly matters to me. I am just taking a part of string. Okay, just to uh, make you clear the things, that's it. Okay, so on Q0, okay, so on Q0 whenever A is read we will move to state Q1. Okay, and the read head will move one position ahead. If you do not know all these things, then please watch my second lecture on TOC, in which I have given the brief introduction about finite automata. Okay, I have already told that FA consists of tape of infinite length divided into cells. One cell store one symbol at a time. We have a read head. One end of the read head is connected to tape, while other end is connected to finite state control mechanism, which store the state of machine. Okay, so initially we are at state Q0 because we have read nothing from the tape. So initially we are at state Q0, that is our initial state, and on Q0 we have read the A. So where we will go, we will see this NFA and we are going to Q1 state. So we are at state Q1 and read head has moved one cell to the right because it has already read this A. So it will move one cell to the right. That is, now read head will be placed exactly here. Okay. Okay. Now on Q1, A is read. Now what can we do? Okay, on Q1 A is read, then we can move to state Q3. That is, this is our first option. The first option is on reading Q1, on reading A, it will move to the state Q3, and since it has read this A, so read head will move one symbol to the right. Okay, so that means our scenario will be like this. Okay, so we will be at state Q3. This is the first case. Okay, second case can be, since we have a null move to the state Q2, that means what, on Q1 after reading null we are going to Q2. See, this is a rough way of saying that on Q1 after reading null. Null means what? Nothing. Null means nothing. It is a free air, so we cannot read it. That means what, on Q1, technically now I'm saying, please listen it carefully, on Q1 without reading any symbol we are going to Q2. That means what, on Q1 without reading any symbol we are going to Q2. So FSCM or finite state control mechanism will now store Q2 in place of Q1. And since we have read nothing from the tape, so read head will be placed here only. That is, it won't move one symbol to the right. Okay, now on Q2 after reading A we can move to Q4. So on Q2 after reading A we will move to state Q4. Okay, so now the finite state control mechanism will store Q4. Okay, so we have two choices. I hope you have properly got this point. We have two choices. The first choice is on Q1. Okay, the first choice is on Q1 we properly read the A. Okay, on Q1 we properly read the A. So after reading A we will move to state Q3. That is a very simple case. Second case is on Q1, whenever we are at Q1, you read nothing from the tape and we move to state Q2. Now on Q2, we read the A and we move to Q4. Okay, so we have two choices on Q1 itself. On Q1, we have two choices. See, we have two choices on Q1, that is without reading anything, either go to Q2 or after reading A, you move to Q3. Since we have a choice, and choice means always NFA, it will never be DFA. Okay, please remember this fact. As soon as you saw null move, then directly say that it is NFA. It is not. It will not be a DFA. Okay, I hope you have got the point. I have repeated several times. Okay, so see, I have written this line. Since we have a choice, so if null moves are present, then we always have NFA. Okay, I hope you have got the point. So let us see some examples. In GATE 2012, this question came. So the question is, what is the complement of the language accepted by NFA shown below? Okay, and assume sigma is A. That means string are over A only, and null is the empty string. Okay, now tell me what will be the language accepted by this NFA, or rather we are saying complement to the language accepted by NFA. Complement simply means that the strings which are not accepted by NFA, you have to list down those strings only. Okay, so complement means what? Let me use different color. Complement means what? Complement of the language means what? Strings which are not accepted by NFA. Just list down all these strings. Strings not accepted by NFA. Not accepted by given NFA. Okay, strings which are not accepted by given NFA, you just have to tell me all those strings. Okay, so so let me do it, you can say in a naive way, or you can say trivial way. Okay, see, on initial state, whenever A is read, we are going to final state. So string A is accepted. Okay, string A is accepted. Okay, or let me do it this way also. See, since initial is not final, and there is no null move from initial to final, so I will say null is rejected. Okay, and we have to list down all those strings which are not accepted by NFA. So the language which is not accepted by NFA will contain string null. Since language is set of strings, so we have to write this curly bracket na for the strings. Okay, so null is rejected. Okay, so since null is rejected, so complement of the language will contain null, because in complement we always have to say the strings which are not accepted. Okay, so null is rejected. Now A is accepted. You can easily see A is accepted. Now what about my double A? Double A means what? From initial state, after reading A, we are moving to final state. Now without reading any symbol, we can move to this state. Now again, without reading any symbol, we can move to this state. Okay, now after reading A, we are at final state. So that means what? Double A is accepted. Now triple A. Now after 1A, we are at final. After reading null, or you can say without reading any symbol, we are at this state. Without reading any symbol, we are at this state. Now after reading A, we are at this state. So double A is accepted. Now after reading without reading any symbol, we are at this state. Without reading any symbol, we are at this state. After reading A, we are at this state. That means what? Triple A is accepted, and so on. You can check it out. Each and every string will be accepted except null. Okay, except null, each and every string will be accepted. Hence we will say that language complement of the language accepted by this NFA will contain only one string, that is null itself. So option B is correct. Okay, this is very simple question. I hope you have got this. If you are not able to follow, then please rewind the video and watch it again. Okay, now let's move to next question. This is again a very simple question. Okay, so let's do it. Okay, so on Q0, we can read any number of A's and we will remain at Q0 only. Okay, so we have a self loop of A. That means what? We can read any number of A's. Either you read 0A, 1A, 2A, 3A, or so and so on, any number of A's. Okay, after reading any number of A's, we can move to Q1 also. Okay, without reading any symbol, we can move to Q2. Okay, so that means what? We can read any number of B's on Q1. Then without reading any symbol, we can move to Q2, and on Q2 we can read any number of C's. Okay, and Q2 is our final state. Okay, so tell me what will be the language accepted by this NFA. Okay, so let's concentrate on the smallest possible string which will be in the language. That means which will be accepted by this NFA. Smallest possible string will be, okay, see, now tell me one thing. Okay, null will be accepted or not? Null will be accepted or not? Please pause the video and try to answer this question. Null will be accepted or not? Yes, obviously it will be accepted, because on Q0 we will say without reading any symbol we can move to Q1. On Q1 without reading any symbol we can move to Q2. That means what? Directly and indirectly we are saying that initial state is also final. That means from Q0 without reading any symbol we can move to Q2, and on Q0 without reading any symbol we can move to Q1, and from Q1 without reading any symbol we can move to Q2. That means what? Initial is final. Indirectly we can say like this. Hence null will be accepted by this NFA with null move. Okay, so this null will be accepted by this NFA with null move. Okay, now Now let's concentrate on single A. Single A is accepted or not? Yes, single A is also accepted because you can directly see from here that after reading A we are at Q0. Now since we are at Q0, then we can move to Q1 also without reading any symbol, and from Q1 we can move to Q2 also without reading any symbol. Hence single A is also accepted. Okay. Now I think it will be trivial for you to guess double A, triple A, and so on. That means any number of A's are accepted. Now after reading A's, any number of A's, we can read any number of B's also. Okay, after reading any number of A's, we can read any number of B's also. And after reading any number of B's, we can read any number of C's also. Okay, so the language accepted will be L will be A power N, B power N, C power P, such that NMP greater than equal to 0. Okay, please try to figure it out. Okay, please try to take string from this language and try to see that all the strings from this language will be accepted or not. Okay, please see here I have used N, M, and P. So these N, M, and P are not related with each other. That means N greater than M, N greater than P, M less than P, and so on. I have not used any kind of relation between them. So we can have simply, I can say any number of A's followed by any number of B's followed by any number of C's. Okay, if you are able to grasp this language properly, then please try to answer me that AC will be accepted or not. AC will be obviously accepted. Why AC will be accepted? After reading A, we will at Q0. Now without reading any symbol, we can move to Q1. Now without reading any symbol, we can move to Q2, and on Q2 we can read a C. Okay, so AC will be accepted. Now here also AC is represented here. Yes, obviously it is represented. Take N is equal to 1, P is equal to 1. So A and C. M you take as 0. So a string will be AC. I hope you have got the point. Okay, so now I think this will be a kind of toy for you. Just try to play with this. You will get many things. You will be able to know lots and lots of things about this NFA with null move and so on. Okay, and just tell me one thing also. One thing more, please tell that BA will be accepted or not. BA will not be accepted. Why BA will not be accepted? Because on Q0, if you want to read a B, then since on Q0 we cannot read a B, na, so we will take the null move and we will move to Q1. Now on Q1 we can read the B. After reading B on Q1, how we will be able to read A? On Q1 B, on Q1 we cannot read A. Okay, and on from Q1, after reading null, or you can say without reading any symbol, we can move to Q2. And on Q2 only C, we can read only C. We cannot read A on Q2. So on Q1 also we cannot read A. On Q2 also we cannot read A. So BA will be rejected. Okay, that's why I have said the language is any number of A's followed by any number of B's followed by any number of C's. Okay, so after A, B can come, but B cannot come after A. Sorry, after A, B can come. Okay, but after B, A cannot come. Okay, I hope you have got the point. And similarly, after C, B cannot come. After C, A cannot come. Okay, I hope I have made the point clear to all of you. Okay, now let's move to next question. This question is from GATE 2017. Okay, this question is also very easy. Just try to focus here. Okay, so let me read the question for you. Let delta denote the transition function and delta cap. Okay, delta cap denote the extended transition function of null NFA. That means NFA with null move, whose transition table is given below. Okay, so this transition table is given. Delta cap is known as extended transition function. Okay, so we are not going in pretty much detail about what is delta cap and so on, since this is a basic course. So I will try to explain it in more precise and very short form. Okay, so please try to concentrate. Okay, so so this is your you can say transition table for the NFA with null move, and they want us to find out delta cap Q2 ABA means what. Okay, so delta cap Q2 ABA means see, set of states. Delta cap basically here denote the set of states. Okay, set of states which are reachable from Q2, set of states which are reachable from given state, or and here given state is what? From given state, that is Q2, set of states which are reachable from the given state after reading string ABA. Okay, so after reading the string ABA, which are the states or you can say which are the set of states which are reachable from the Q2. Okay, so we need to find this thing. Okay, so for this we need to follow very basic or very simple steps. So step number one is first find epsilon closure of Q2. So let me tell you, let me introduce a new term, that is epsilon closure. Null or epsilon is one and the same thing. So I'm writing null closure, or you can say epsilon closure. Epsilon closure means set of states, or you can say, let me do it precisely, epsilon closure of state. Epsilon closure of state. The definition of epsilon closure says set of states which are reachable from the given state, set of states which are reachable from the given state, without reading any symbol, okay. The condition is that you need not, or you should not read any symbol, okay, you should not read any symbol, and still you are able to reach somewhere. Okay, so set of states which are reachable from the given state without reading any symbol, or you can say by or roughly you can say without roughly we can say read any number of null. Okay, read any number of null, and set of states which are reachable from the given state, that is known as epsilon closure of state. Okay, I hope you have got the point, but if you are still not able to follow, then please bear with me, just give me 2-3 minutes, you will be able to get everything. Okay, so epsilon closure is this thing now. So now try to find epsilon closure of Q2. Okay, so step number one to solve such kind of question, step number one is, since we need to find set of states which are reachable from Q2 after reading ABA, so first find epsilon closure of Q2. Epsilon closure of Q2 will be what? C Q2. Okay, on Q2 by reading null, or you can say see, I'm roughly saying reading null. Null is nothing, so we should say precisely that without reading any symbol. So we should say on Q2 by without reading any symbol we can go to Q0, and on Q0 by without reading any symbol we can go to Q2, and from Q2 without reading any symbol we can go to Q0, and so on. So I think you have got the point that epsilon closure of Q2 will contain Q0 and Q2. Only two states will be there now. See, on Q2 without reading any symbol we are going to Q0, and on Q0 without reading any symbol we are going to Q2 only. So final answer will be what? Epsilon closure of Q0. Okay, so we epsilon closure is denoted by delta cap Q2 comma null. This is epsilon closure. So delta cap Q2 comma null will be what? It will be Q0 Q2. Okay, now just try to find on Q0 after reading A where we are going. See, on Q2 we need to on Q2 we are reading the string ABA now. So first symbol which we are going to read is A on Q2. So on Q2 we are reading A now. So on Q2, see on Q2 we are reading A, we are going nowhere. So what should we say? That we are going nowhere? No, we cannot say like this. First we need to find epsilon closure of Q2, and epsilon closure of Q2 contain Q0 Q1. So now try to apply A on Q2 as well as on Q0. So why we are applying? Because this is very simple idea. See, on Q2 without reading any symbol we can go to Q0 now. On Q2 without reading any symbol we can go to Q0 now. So on Q0 we can read it. Okay, so on Q0 we can read it and we can go to Q1. Okay, I hope I have got the point clear to all of you. See, if you are not able to follow, just remember one thing, that you need to find epsilon closure of the given state, that is Q2. Epsilon closure of given state is Q0 comma Q2. So on Q0 you have to read A, and on Q2 also you have to read A. On Q2 after reading A we are going nowhere, and on Q0 after reading A we are going to Q1. Now we are at Q1. Okay, now we are at Q1. Now again find the epsilon closure of Q1. Epsilon closure of Q1 we need to find. So Q1 on Q1 without reading any symbol we are going to Q2. Okay, so let me write here. See, delta cap Q1 comma null, that will be equal to, see, on Q1 after reading null, or you can say without reading any symbol we are going to Q2 now. So Q2 you have to write. Okay, now next on Q2 after reading null or without reading any symbol we are going to Q0. So you have to write Q0, and on Q0, okay, and on Q0 without reading any symbol we are going to Q2. Q2 is already in the set. And please remember one thing, since we are at Q0 without reading any symbol, we are still at we will still remain on Q1 only. So you have to write Q1 also. You have to write Q1 also. Okay. So we epsilon closure of Q1 will see. This is a simple rule that epsilon closure of each and every state will contain the given state itself. Epsilon closure of Q1 will contain Q1. Epsilon closure of Q2 will contain Q2. This is but obvious thing because without reading any symbol, we are at the given state only. Okay. So epsilon closure of Q1 will be Q2, Q0, Q1. So now I can say delta cap Q2 comma A. I have solved this part that let me write here. Okay, or let me use a different color. See, now till now I have solved that delta cap Q2 comma A will be what? It will be Q2, Q0, Q1. Why I have got this? This is very simple idea. See, on Q2 we are reading A now. So first step number one is find epsilon closure of Q2. We have find epsilon closure of Q2 as Q0, Q2. Now on Q0 we read A, and on Q2 also we read A. Now on Q0 we read A, we go to Q1, and on Q2 we read A, then we are going nowhere. So finally we are at Q1. Now since we are at Q1, now try to find epsilon closure of Q1 also, that is Q2, Q0, Q1. So now I can easily say that delta cap Q2A will be Q2, Q0, Q1. So after reading A on Q2, we can reach Q2, Q0, and Q1. These three states. Now just copy paste the same idea. That is now on Q2 you will read a B. We have partially solved this question. We have solved for A. Now after A we are reading B now. So now try to apply B or try to read B on all these three states. Okay. Now see, I have all to save the time, I have already given the steps. Okay, so just read the steps. Now starting from Q2, input string is ABA. Step number one, find epsilon closure of Q2. That will be Q2, Q0. We have already solved. Now find transition on A. We have already solved on transition A. On Q0, we are going to Q1, and on Q2, we are going nowhere. So finally, we have got Q1 as our state. Now find epsilon closure of Q1. That will be Q1, Q2, Q0. Now till here, we have find this thing, delta cap Q2 comma A. We have find that will be Q1, Q2, Q0. Now we need to apply B. Okay, now the next symbol, see the previous slide. The next symbol we are going to read is B. Now A is solved. Now we have to read B. Now try to read B. So for reading B, now see, now find transitions on B. So on Q1, after reading B, we are going to Q3. Please check the table. I'm not I want to save time. So please, I hope you have made this table in your notes. So just see the table, and I will just read it from here. Okay. So on Q1, after reading B, we are going to Q3. Q0, after reading B, we are going to Q0, and on Q2, we are after reading B, we are going nowhere. Okay. So now find epsilon closure of C. We are getting two states as output now, Q0, Q3. So now try to find epsilon closure of Q0 as well as Q3. So find epsilon closure of Q0, Q2, and epsilon closure of Q3 is only Q3. You can check it out. See, Q3 on reading null, we are going nowhere. That means on Q3 without reading any symbol, we are going nowhere. So epsilon closure of Q3 will be Q3 itself. Okay. So now we will union all these. Okay. So Q0, Q2, Q3, Q0, Q2, Q3. This will be my final answer. So now I can say till here, I have solved delta cap Q2 comma AB. That will be Q0, Q2, Q3. Okay. We have solved till now this part. Okay. Now after reading B, we are going to read A now. So now next, see here, find transitions on A. So Q0 on reading A, we are going to Q1. Q2 we are on reading A, we are going nowhere. Q3 on reading A, we are going nowhere. So finally, we are getting Q1 as output. So now try to find epsilon closure of Q1. Epsilon closure of Q1 will be Q1, Q0, Q2. So therefore, answer C is correct. Okay. So please check the answer in the previous slide. So answer C will be correct. Q0, Q1, Q2. Okay, I hope I have made the point clear to all of you. If you are still not able to follow, please rewind the video and watch it again. Okay, so now we have completed your NFA with null move topic. Okay, we have completed this topic. Now let's move to the next topic according to syllabus of your second chapter, that is finite automata and regular languages, that is MEALY MOORE machines. Okay, so let me give you a brief introduction. See, finite automata is of two types, acceptors and transducers. Acceptors are these NFA, DFA, NFA with null move, which we have already studied. So in these and to acceptors, we are giving input as a string and output is yes or no. Yes means what, string is accepted, no means string is rejected. Okay, so there as the name suggests, their work is just to accept or reject the string. That's it. Okay, but transducer, that is MEALY MOORE machine, these are used to generate string as output. Okay, so input is a string and output is also a string. So we are giving input as a string, and now we are getting output as a string only. So that is the basic use of transducer. So now we are not interested in string acceptance or rejection. We are interested in getting some output string. Okay, that is transducer. Okay, so we are going to study two transducers, that is Moore machine and Mealy machine. Okay, so in the end of TOC, I will also explain that Turing machine also act as a transducer. Okay, so we will study all these things. Don't worry. Okay, now Mealy Moore machines are represented by 6 tuple. Okay, so M, or you can say your machine M, will be represented by 6 tuple, that is Q sigma delta Q naught, capital delta and lambda. Okay, so let me revise you one thing. See, by FA, or you can say transduce your acceptors. Okay, acceptors, we were I used to say that acceptor is represented by 5 tuple, na? 5 tuple. Just tell me which were those 5 tuple. Pause the video and please write yourself. Acceptors were 5 tuple, that is Q sigma delta Q naught and F. Okay, I hope you all remember this thing. So see, Q sigma delta Q naught, all these things are copy pasted, and final state was what? It was used to accept the string now. But here in case of acceptor, we want to accept the string now. So we have final state, and we say that starting from initial state, after reading entire input string, FA must be at any one of the final state. We used to say this statement. So string were accepted when from initial state. From initial state, we move to final state. But here, since we are not interested in acceptance or rejection of strings, so final state won't be present in and it won't be present here. Okay, so in 6 tuple, we do not have final state. See yourself. Okay, so Q sigma delta Q naught, all these things are copy pasted, and we have two new tuple, that is capital delta and lambda. Capital delta is your output alphabet. Okay, see, sigma is your input alphabet. Now that means the string which we are going to input to these machines. Okay, string which we are going to input to these machines. So how this string will be constructed, or from which input alphabet this string will be constructed, that will be obviously given by sigma. Okay, sigma will give us information about which type of string can be inputted to the transducer or the given Mealy Moore machine. Like sigma is say a comma b, then we can give string from a comma b only. Okay, and if the string is from say if sigma is 0 comma 1, then we can give string over 0 and 1 only to the Mealy Moore machine. Okay, now what is the output string? Now since we have getting output as a string itself, so this string will be constructed from this capital delta. Okay, so capital delta is say a comma b. That means what? We are going to input string, we are going to input string in the binary format, that is 100110 and so on, like this, and output string will be like this, a b b and so on. Okay, so capital delta correspond to the output alphabet, and the sigma correspond to the input alphabet. Okay, you already know all these things, sigma and so on. Okay, so delta will be output alphabet. Okay, so let me do it in a serial fashion. Q, capital Q is the non-empty finite set of states. We have already studied these things in finite automata. Okay, that is your acceptor. Okay, sigma was your input alphabet. That means the string which we are going to input to the Mealy Moore machine. Okay, that will be constructed from sigma. Delta is your transition function, and please remember, transition function is just like DFA. For Mealy Moore machine, transition function is just like DFA, and once the in match the following, in GATE exam question already came about Mealy Moore machine, that Mealy Moore machine are your, you can say, corresponds to what kind of machine? They are deterministic finite state automata. Okay, so these are just like your DFA. Okay, so please remember this thing. Let me use a different color and highlight this fact that delta will be Q cross sigma implies Q, that is input transition function. Okay, so delta will be just like your DFA only, Q cross sigma implies Q. Okay, now next is initial state. Q naught is your initial state, delta, capital delta is your output alphabet. I have already told that our interest is in not acceptance or rejection. Our interest is in generating string. So the string which we are going to generate as output, that will correspond to that string will be made from this capital delta, that is AB. I have given you example also. For example, I have given input like 1011 and output will be like AB like this. Okay, so I hope I have made the point clear to all of you. Now next thing, delta. Delta is you can sorry, lambda. Lambda is the heart of machine. Okay, here lambda is the heart of machine, and that is the output transition function, or you can say output function. Output function or output transition function, one and the same thing. So lambda will correspond to according to lambda, we have divided machines into two categories, that is Mealy machine and Moore machine. So according to lambda, we have divided machine into two categories, that is Mealy machine and Moore machine. Mealy machine is like Q cross sigma implies delta star, and Moore machine is like Q delta star. Okay, so in simple wording, I can say Mealy machine say we are at any state Q, and after reading any input symbol, then output will be generated. So state, input, output. Okay, this is the basic rule of Mealy machine. Mealy machine say state, input, output. Moore machine says state, output, state, output, state, output, like this. Okay, so if we are at given state, then we will get an output. That is the basic meaning of Moore machine. And in Mealy machine, we are at any state, we will not get output. After reading any symbol, then we will get some output. Okay, delta star means any symbols, na? So Q cross sigma implies delta star. That means state, input, then output, then state, output. Okay. So I will keep on saying all these things, but I know you won't be able to get proper thing until I will show you some examples. So let me show you some examples. See, for example, here delta, lambda Q1 0, that will be null. That means what? On state Q1, after reading 0, output generated will be null. See, null is present in delta star, na? You know all these things. Okay, so now on Q2, after reading 1, we are getting output as AB. Okay, AB. We are, see, delta star, na, then all possible strings over delta. That means delta star, na? So AB I can get. Okay, on so here state output means what? Lambda Q1 is equal to A. That means what? We are at Q1, we will immediately get output A. We are at Q2, we will immediately get output B. This is the basic meaning of Moore machine. Okay, so we have two ways to represent Mealy Moore machine. Just like NFA, DFA, we were having two ways, that is state transition diagram and table method. So here also we have two ways, that is state transition diagram and table method. Okay, so let me show you one example of Moore machine. See, this is an example of Moore machine. So as soon as you get a state transition diagram, how will you identify that this is a Moore machine? Very, very simple. See, with state, we are getting some output. With state, we are getting some output. With state, we are getting some output. That is the basic meaning of Moore machine. And how will you identify Mealy machine? See the next example. In Mealy machine, see, state, input, then we are getting some output. State, input, then we are getting some output. State, input, we are getting some output. State, input, we are getting some output. This is the example of Mealy machine. So in Mealy machine, along with state, we are not going to write output. We are going to write output on the arrows itself. Okay, that means what? State, input, then output. But in case of Moore machine, along with state, we are getting output, or we will write output. Okay, so with state / output, that means what? Moore machine. Okay, now if output is given on the arrows, that means it is a Mealy machine. I hope you have got the point. Okay, now this is the state transition diagram, and table method will be very, very simple like this. So on Q0 is the initial state. Now we are giving arrow, and see, there is no final state. There is no double circle on any state. Why? Because we do not really need that final state, because we are not interested in acceptance or rejection of string. We are just interested in getting some output. Okay, I hope I have made the point clear. Okay, now on Q0, after reading 0, we are going to Q1. Q0, after reading 1, we are going to Q2. See from here, I have just copy pasted your state transition diagram in the table method itself. And from the table method, how will you identify this is a Moore machine? See, we have input and output only one column. That means what? On Q0 output will be null, Q1 output will be 1, Q2 output will be 0, and so on. Okay, I hope I have made the point clear to all of you. Okay, so now let me give you some example and show how this machine is producing output. Okay, so let me take some input string. The basic idea of Mealy Moore machine is what? We are giving some input and we are getting some output. Okay, so input string here, let us take input string as 1011. Okay, this is your input string. Now let me show you precisely on Q0. Okay, without reading any symbol, we are at Q0 now, and Q0 output is what? Null. Okay, so we got null. Now on Q0, we are reading 1. See, we are reading 1. On Q0, we are reading this 1. Now on reading 1, we are moving where? On reading 1, we are moving to Q2. We are moving to state Q2. Now Q2, as soon as we go to Q2, Q2 output is showing as 0. So we will get output as 0. Now on Q2, we are going to read this 0. 0 is read. Now on Q2, after reading 0, we are going to Q1. And as soon as we jump to Q1, output will be what? 1. So we will get output as 1. Now on Q1 we are reading 1. Read 1 on Q1. We are going to Q2. Q2 output will be what? Q2 output will be 0. Now on Q2 we are reading 1. On Q2 we are reading 1. We will remain on Q2 itself. We will remain on Q2 itself, and output will be what? 0. Output will be 0. Okay. So just try to see. We have given input as 1011, and output is what? Leave the null. Okay, because null dot something is null only. Leave this. We are not interested in null. Null means nothing. So output is 0100. 0100. See carefully what this machine is doing. This is doing ones complement. So this Moore machine is giving us ones complement of the given number. Ones complement of given number. Okay. So see, this is your introductory course, or you can say basic course. So I am not going in more detail about Moore machine and giving you more examples and so on. I have just given you idea about how actually Moore machine look like and how to find the output. That's it. Okay, this is more than sufficient for all of you. And in the advanced course, I will teach you more and more examples of Moore machines and so on. Okay, so please note it down carefully. Okay, now let's move to next slide. Okay, so let me show you. I hope you have noted down. Now let me show you Mealy machine. Okay, so this is a example of Mealy machine. Okay, so why this is a Mealy machine? Because with state itself we are not writing output, but on arrows we are writing output. That means on transitions we are writing output. So Q0 on after reading 0, we will get output as 0 and so on. Okay, so now and here also see, this is your state transition diagram and this is your table method. So in table method, how will you identify that this is a Mealy machine? We will have alternate columns, input output like this. Okay, so on Q0 after reading 0 we are going to Q0 and output will be 0. On Q0 after reading 1 we are going to Q1 and output will be 1 and so on. Okay, so input output like this. So we will have alternate column. That means it is a Mealy machine. But if the last column is output and rest every column is input, then this is a Moore machine. Okay, just remember these things. Okay, now tell me what output we will get. Okay, so let's give some input and try to find what output we are going to get. Okay, so let me take a very simple example. Say string is 1100. Okay, or you can say 1100. Now what will be the output? So we will start from initial state Q0. Okay, let me use a different color. We will start from initial state Q0. Okay, now Q0 won't give us any output now because this is not Moore machine. After reading any symbol, only then we will get some output now. Okay, so first symbol we are going to read is 1 now. So now Q0 on reading 1, we are moving to what? See from the table. On Q0 reading 1 we are going to Q1, or from here also we can say on Q0 on reading 1 we are going to Q1. Okay, so we are going to Q1. And now our output will be generated, and output is what? Output is 1. Output is 1 now. So just write here, output will be 1. Now on reading next one, we are going to state Q1 only. Okay, and output will be what? 0. Output will be 0. On reading 1, we will remain at Q1 only, and output will be what? 0. When Q1 1 is read, then output is 0. See carefully. On Q1 reading 1, we are getting output as 0. Now on Q1, okay, see we have read these 3 1. Now on Q1 we are reading 0. On Q1 we are reading 0. We will remain on Q1 only, and output will be 1. And on Q1 we are reading 0. We will remain on Q1 only, and output will be 1. So final output will be 10011. Okay, this will be our output. So 11100 is our input, then output will be 10011. Okay, now let me tell you a very good that what exactly this machine is doing. See, all these machines are imaginary machines. Now since these machines are imaginary machine, so we can give instruction to these machines that how exactly we are going to input the string. Okay, see here also in Moore machine also we can give instructions that ignore first two output symbols, ignore first three output symbol, and so on. We can give any number of instructions to the machine because all these machines are imaginary machine. Or you can say that input is 1011, then reverse the input, then give this machine as input, and so on. We can give any kind of instruction, whatever instruction you want you can give to these machines because all these machines are imaginary machines. Okay, so now let me give one instruction here. Now my instruction is that if you want to input any string now, then just reverse it and then give it to this machine. Okay, now see how output is going to be generated. Your input was 11100 now. Your input was 11100. So first reverse the input and then give this input to this machine. Okay, first reverse this string and then give it as input to this machine, and then see what output is going to be generated. Okay, or you can say that the input is 11100. So now we will give instruction to machine that start from the last symbol, not start from the first symbol. Okay, and start from the last symbol, and your read head will move from right to left like this, just like Urdu. Okay, from right to left we will move. We can give this instruction, or directly say that just reverse the string and then give this as input to this machine. Okay, whatever way you want you can use. Okay, so let me say that we are first reversing the input and then we are giving it to this machine. So now see what exactly output we are going to get. Okay, so see, first we are going to write 0 now. Okay, so let me take another slide, or let me do it here only. Okay, let me do it here only. On Q1, sorry, on Q0 is the initial state now. Q0 is the initial state. We are reading 0. We are giving reverse input now. On reading 0, we will remain at Q0 only, and output will be what? 0. See here, on Q0, on reading 0, output will be 0 only. Okay, now again we are reading 0, we will remain at Q0 only and output will be 0. Now on reading 1, we are going to Q1, output will be 1. On reading 1, we will remain at Q1, output will be 0. And on 1, we will remain at Q1 and output will be 0. Okay, please try to follow this. I have said this in pretty faster manner. Please try to recheck all these things. So we will get this as our output. Okay, we are going to get this as our output. So the string input was 11100, and the output is what? Output is, let me say it this way, this is our output. So that means what? See the way I have written. This is nothing but 2's complement. This is nothing but 2's complement. So this machine is finding 2's complement of the given number. Okay, just try to follow this thing. So please, if you are not able to follow, just try to rewind the video and try to watch it again. So I'm just saying, see, in the simple wording I can say, you know how we find 2's complement of a given number? If the input number is say 1100, so 2's complement will be what? Scan the number from right to left. Okay, just write all the zeros and copy paste the first one, and then you will say one's complement of the remaining number. Okay, so first one as it is, then you will find the one's complement of the remaining number. You will find one's complement of the remaining number. So this is your 2's complement. This is the shortcut to find 2's complement. One of the way to find 2's complement is what? Just find the one's complement and then add 1. But the another better or shortcut way is, see, if you are finding one's complement and then adding 1, we need 2 steps. But in one step also we can find 2's complement. And the better way is, see, if the binary number is 110, 11100, then all the trailing zeros you just copy paste, and the first one is copy pasted, and then the remaining string will be, we will find one's complement of the remaining string. So first 0 as it is, second 0 as it is, first 1 as it is. As soon as you get 1, you will copy paste that 1, and then after that you will find the one's complement of the remaining number. Here also see what we are doing. If input is 0, output is 0. Input is 0, output is 0. So all the zeros, see, we are inputting string from right to left now. So all the zeros will be copy pasted, and the first one will be copy pasted, and then see we are doing ones complement. If input is 0, output is 1. If input is 1, output is 0, and so on. I hope you have got the point. Okay, so this machine is finding whose complement of the given binary number. Okay, so if you want to construct a Mealy machine, okay, so just try to first note it down. Okay, just try to note it down. Let me show you the previous slide. Please note it down. Okay. I hope you have got the point. If you are still not able to get, please rewind the video and watch it again. Okay. Now let me give you a small idea, or you can say brief idea about the you can say Mealy machine to find one's complement. Mealy machine to find one's complement. One's complement. This is very easy. I hope you have already got the idea about how to find one's complement. Okay, so Mealy machine is very simple, na? Okay, let me write it properly. One's complement. One's complement machine. See, very simple. We will have only one state Q0. On reading 1, we will get output as 0. On 0, we will get output as 1. That's it. So this is one's complement machine. You can check it out yourself. Please try to give input string. This is homework for you. Okay, just try to give some inputs. Okay, just try to give some input and find some output. So homework for you is try to give this string and find the output, and try to give this string and find the output. You will get the ones complement. Definitely you will get the ones complement. Why? Because on reading 1, output is 0. On reading 0, output is 1. That's it. So it will find ones complement. Okay, so these machines are very easy, and we have ways to convert Mealy machine to Moore and Moore to Mealy. Okay, but we are not showing all these things in this lecture because these are advanced topic, you can say, and we will learn all these things in the advanced TOC course. This is a 20-hour course, and I have to complete entire TOC in 20 hours. So I think you have guessed that I will cover basic concepts in these lectures only, because this is a foundation course on TOC. This is not an advanced course. Okay, so you can say converting Mealy machine to Moore and Moore to Mealy. We will study all these things in the advanced course. Okay, now let's move to the next topic. That is the 7th topic according to syllabus of your TOC. The second chapter, that is Finite Automata and regular languages. That is the grammar. 7th topic is grammar. Grammar is what? Grammar is used to generate the strings. Okay, so FA is used to accept the string, as we have already said. Finite Automata is what? Your NFA, DFA, and so on. So all these machines are used to accept the string, na? And these grammars are used to generate the strings. Okay, so formal definition is grammar is defined by 4 tuple. This is a 4 tuple, that is NTPS. Some book says N as V. N means what? Non-terminal, or you can say variable also. Some book says N as V. Okay, some book says N as V, VTPS or NTPS, you can say anyway. Okay, NTPS or VTPS. Okay, so N is what? Non-empty finite set of non-terminals. T is what? Finite set of terminal symbol. P is what? Production rule. Production rule is the heart of your grammar. This is the main part. You can say heart of grammar. Heart of grammar is production rule. Okay, and S is your start symbol. Okay, S is the start symbol. N is non-empty finite set of non-terminal. T is finite set of terminal symbol. P is production rule or heart of grammar, and S is the start symbol. So these are the 4 tuple. And what is a non-terminal? I have said this. Non-terminal is what? Used to generate non-terminal or terminal symbols, and these are generally represented in uppercase. I know you won't be able to get anything from these from this slide, but slowly when I will move to examples, then you will get each and everything. So non-terminal is what? N is what? Non-empty finite set of terminal, finite set of non-terminal. Non-terminal means what? Which are used to generate non-terminal terminal symbols. That means you can say these non-terminals can generate something, and what they can generate? They can generate non-terminal or terminal symbols. Okay, and these are generally represented in uppercase. T is what? Finite set of terminal symbols. And see here, please note it down carefully. N is non-empty, na? And T, I have not said anything about T. That is finite. So empty set is also finite. So terminal symbol can be empty also. Okay, so in grammar we can have grammar in which we do not have any terminal symbol. Okay, see, so T is what? Finite set of terminal symbol. Terminal symbol means what? Basic or fundamental symbol, and these can't generate terminal or non-terminal. Okay, so these are basic or fundamental symbols. These cannot generate terminal or non-terminal symbols, and that is these are atomic in nature. That means we cannot further subdivide them, and these are generally represented in lowercase. These are generally represented in lowercase. These are known as terminal symbols. Okay, so don't worry, please. If you are not able to get anything, don't worry. When I will show you example, you will get everything. So non-terminal means what? These are, you can say these can generate something. Non-terminal means what? These are not terminating. Not terminating means what? They can generate something. What they can generate? They can generate non-terminal or terminal. Terminal symbols which are terminated. That means what? These cannot generate anything extra. So that means what? These are basic or fundamental symbols, and these can't generate terminal, non-terminal. These are represented in lowercase. Production ruler, heart of machine. I will show you after few slides. Production rules is nothing but heart of grammar. Okay, now S is the start symbol. Okay, let me move to some example. This is a very simple example. Okay, so see, I have taken example of English grammar itself. See, in English we use grammars to we use grammar in English so that we can write proper sentences in English. Na? So to generate, or directly indirectly we can say grammar is used to generate valid sentences in English language. English grammar is used to generate valid sentences in English language. Similarly, Hindi grammar, or you can say Vyakaran, is used to generate sentences in Hindi language. Okay, so hence in TOC also grammar is used to generate strings. It is used to generate strings. Okay, so I have taken example of English so that you can get everything properly. Sentence is what? Noun followed by verb. Noun can be Ram, noun can be Sham, verb can be eating, verb can be playing. Okay, so sentence is noun followed by verb like this. Okay, so just tell me four tuple. Na grammar is four tuple, so please tell me what are these four tuple. N is what? Non-terminal. Na non-terminal will be what? Sentence, noun, and verb. These all are non-terminals. Okay, so non-terminals are set of non-empty set. Na? So please write it in the set format, that is in curly bracket. So it will be sentence, sentence, noun, and verb. These are non-terminal. Terminals are what? Ram, Sham, eating, playing. Ram, Sham, eating, playing. Okay, so these are what? Let me write it properly. Ram, Sham, eating, playing. Okay, so these are what? Terminal symbols. So these here, na Ram, Sham, eating, playing, all these are terminal symbols. Production rule, all these are production rules. Okay, so whatever we have written here, these all are production rules. So 5 symbols, no? Sorry, 5 rules. These all are production rules, 5 rules. Okay, now what is the S? That is start symbol. I hope you have guessed it right. That is sentence. Sentence is the start symbol. Okay, sentence is the start symbol. Okay, now let me introduce some terms. See, if still you are not able to get something, please do not worry. I will show you lots and lots of examples. Okay, so sentence implies noun followed by verb. Noun is producing something. Na? Noun is producing Ram, noun is producing Sam, verb is producing eating, verb is producing playing. So noun, verb, noun and verb, these are non-terminal. Similarly, sentence is producing something. Na? Sentence is producing two non-terminals, that is noun and verb. I have already said that non-terminal can produce further non-terminals as well as terminal symbols. Okay, so this is why sentence is a non-terminal, because it is producing two non-terminals, that is noun and verb. So sentence is a non-terminal. Why noun is a non-terminal? Because it is producing two terminals. The noun is producing Ram as well as Sham. Okay, verb is producing eating as well as playing. So two terminals are produced by verb. Okay, so hence verb is also non-terminal, noun is also non-terminal, sentence is also non-terminal. And Ram, Sham, eating, playing, these are not producing anything. Na? So hence these are terminal symbols. Okay, Ram is not in the left hand side of arrow anywhere. Na? Sham is not in the left hand side of any arrow. So that means what? These are arrows. Na? So in left hand side means what? They are producing something. Na? So noun is producing Sham, noun is producing Ram, and so on. So Ram, Sham, eating, playing are not in left hand side of any arrow, or you can say they are not in left hand side. So these are terminal symbols. These are not producing anything. Okay, of course I'm showing you a vague definition. Whenever I will show you examples, you will get everything more clearly. Okay, so the best idea is these are in TOC. Na? In TOC, I am showing you this example of English language. When I will move to TOC, or you can say when we will see grammars in TOC, then I will show that non-terminals are in uppercase and terminal are in lowercase. Okay, Okay, so these are the you can say basic meaning. Okay, so Ram Shah meeting link we have studied. Now production rule are these five are the production rule, and S is that is start symbol is sentence. Okay, now let me introduce few definitions. So the first definition is sentence or string generated by grammar. Please write it down carefully because you all will make mistakes somewhere. Okay, at some time you all will mistake some you all will miss something. That's why I have written in, very neatly and very precisely, and in points I have written the definition. Please note it down carefully. Sentence or string generated by grammar is what? Starting from start symbol. You have to start from start symbol. You cannot start from anywhere. You have to start with start symbol. After applying any number of production rule in any order, that means their order is not fixed, their number is not fixed. Okay, so we can apply any number of production rule. Concatenation of any number of, see, terminal, please underline this thing. Concatenation of any number of terminal symbols is known as, is called sentence or string generated by grammar. Okay, I will give you example, don't worry, please note it down the definition carefully. Sentence or string generated by grammar is what? Starting from start symbol, after reading any number of production rule in any order. Concatenation of any number of terminal symbols is known as sentence or string generated by grammar. Next definition is sentential form. Sentential form is what? Starting from start symbol. Again, you have to start from start symbol itself. Please underline this thing. Starting from start symbol. Rather, these all the 3 points are very important. Again, here also underline starting from start symbol. You cannot start from anywhere. Okay, starting from start symbol. After reading any number of production rule, after applying any number of production rule in any order. Okay, you can apply any number of production rules in any order. Concatenation of any number of terminals. See, I have written with another color so that you can differentiate between this definition. Sentential form means concatenation of any number of terminal or non-terminal symbols is known as sentential form. Here in string we have said concatenation of any number of terminal symbols only. We cannot have non-terminal. We need only terminal symbols. Okay. And here we can have terminal as well as non-terminal. Since in sentential form we have choice, that means we can have terminal as well as non-terminal. So every sentential form will be, sorry, every string will be a sentential form. Why every string will be a sentential form? Because, see, I have written this also, not every string is sentential form, but vice versa, not true. Why every string will be sentential form? Because in string we have only terminal, but in sentential form we can have terminal as well as non-terminal. Okay, so hence every string will be sentential form, but vice versa not. Okay, now let me give you some example. You will get everything. If you are not able to get, please now see sentence implies noun verb. Okay, so this is the step number 1. First step we have applied. Okay, or you can say first production rule we have applied. Sentence implies noun verb. First step is over. Now noun is giving us ram na, so noun can produce ram. So this is your second step. Now noun implies ram, so we have got ram verb like this. Now verb can be eating also, so this is your step 3. So here we need 3 steps to generate a string that is ram eating. Ram eating is a string. Now why it is a string? Because it is concatenation of terminal symbols. Ram is terminal, eating is terminal, so we have got concatenation of terminal symbols. Okay, by applying 3 production rule, or you can say 3 steps, 3 steps or 3 production rule, we have got ram eating, that is a string. Okay, so here 3 steps are needed to generate this string ram eating. Now what is this noun verb? This is sentential form. What is ram verb? This is a sentential form. What is ram eating? This is a string as well as sentential form. Please note it down carefully. Noun verb is sentential form. This is sentential form. Okay, ram verb is again sentential form. Ram eating is again sentential form, and it is string also. It is string also. And sentence is what? Sentence is no doubt your start symbol, and it is also a sentential form. It is also a sentential form. Why it is a sentential form? Please read the definition carefully. I have written after applying any number of production rule. Any number means what? 0 or more. So if you have applied 0 production rule, that means nothing you have applied, then we are at start symbol only, na? So hence this is also a sentential form. Please note it down carefully. These things are really confusing for most of the students, so please note it down carefully that sentence is also a sentential form. That is, start symbol itself is a sentential form. Then noun verb is a sentential form. Ram verb is a sentential form. Ram eating is also a sentential form, but ram eating is string also. Why it is string? Because we have only terminal symbols, and from where we are starting? We are starting from start symbol only. Okay, so please apply the definition. Please try to toss all these things in your mind. You will get each and everything. Okay, now I'm not repeating again and again. If you are still having doubt, please rewind the video and watch them again. Okay, so please note it down. I'm moving to next slide. Okay, so next definition is language generated by grammar. Language generated by grammar is what? Set of all strings generated by grammar. So all the strings which are generated by the grammar, or you can say set of all strings which are generated by grammar, that is known as language generated by grammar. Okay, so language generated by grammar G is represented like this, LG. LG means what? Language generated by grammar G. Language generated by grammar G. So here what will be the language? Can you tell me what are the all possible strings which we are going to generate from this grammar? Let me use the previous slide. So see here, let me show you here itself. This is our example now. So sentence implies noun verb. You have to apply this production rule. Now noun can give us Ram Sham. See, I am writing here. Sentence implies noun verb. Noun can be Ram Sham. Noun can be Ram Sham. Verb can be eating, playing. Verb can be eating, playing. So Ram eating, Ram playing. Let me use different color. Ram eating, Ram playing. Now Sham eating, Sham playing. So we will get 4 strings from this grammar. And set of all strings which are generated by the grammar, this is known as language generated by grammar. So our language generated will be, okay, let me go to our slide. Language generated will be language generated will be 4 strings, set of 4 strings. Okay, that is Ram eating, Ram playing, Sham eating, Sham playing. Okay, I hope you have got this point clearly. Okay, Ram eating, Ram playing, Sham eating, Sham playing. So 4 strings are generated by this grammar. So language generated by grammar will be these strings. Okay. Now this is all about your English language. Now let me jump to TOC example. See, this is an example of TOC. S implies AS, BS, or A. So first try to find the 4 tuple, that is NTPS. Since this is your first second example, so I am showing you the tuple, 4 tuple. In the rest examples I won't show this. Okay, I will skip all these things. So that will be homework for you to identify the 4 tuple. So and that is non-terminal. Here we have getting only one non-terminal, that is S. Okay, since S is in capital now. See, in TOC, just remember this rule. Uppercase means what? Non-terminal. Lowercase means terminal. That's it. Okay, so just remember this thing. No need to worry about anything. Uppercase means non-terminal, lowercase means terminal. So non-terminals is only one, that is S. Terminal here is only one, that is A and B. Sorry for that, A and B, na? A and B. Let me do it properly. A comma B. Okay, A and B, na? We are having A and B. Production rule are these. So here we have 3 production rule. We can do slash also. See, one way is like this: S implies AS, S implies BS, S implies A. These are 3 different production rule. And since LHS is same, na, so you can write with slash also. These are very basic thing. I hope you already know all these things. Na? S implies AS or BS or A. Okay, so 3 production rule. So we have 3 production rule, that is S implies these are the production rules. Okay, S implies AS, S implies BS, and S implies A. Write properly in the set format now, because these are set of rules. Okay, now S, that is start symbol, is S only. Okay, or let me write it properly. Start symbol is S only. Okay, we are not using this set format here. Why? Because we have only one symbol as a start symbol. We cannot have 2 or 3 symbol as start symbol. Okay, so please do not apply this bracket here. Okay, so set bracket, no need to apply. You just write S only. This is your start symbol. Generally in all the grammars we will using S as the start symbol, so that we can directly identify that this is S, na? S. Okay, and in various exams also they will show you only production rules like this. Okay, so you can identify the 4 tuple, but we do not need to identify them. They just want, or you can say the question only say what is the LG here, or language generated by grammar, or they will say that whether the given string is generated by this grammar or not, and so on, like this. Questions will come like this. Okay, so LG, so just directly tell me what is the LG, or language generated by this grammar will be what. Okay, so I can say language will be what. See, directly from S we can get A now, we can get A. So in LG we will have string A. Okay, now I can apply production rule like this. S implies AS. Now this S can give us A, so the string generated will be what, double A. Okay, or let me say it here only. A is copy pasted and S will get us A, so double A will be accepted. Similarly, we can have S implies BS and S will go to A, so we will get BA. Okay, now just focus here. S implies AS BS, so that means what, we can have any number of A's and B's. Okay, so we can mix them, or you can say we can mingle up A's and B's. So that means what, we can have any number of A's, B's, and then the string must end with A. So the language generated will be all possible strings over A and B which ends with A. Okay, so let me give you one idea like this. See, is this string will be accepted generated by this grammar or not? Yes, this string will be generated by the grammar. Why? Because see, S implies first symbol is A na, so apply AS. Now second is B, so now apply BS. Now next symbol is A, so now apply AS. Next symbol is B, so now apply BS. Next symbol is A, so S will go to A. So A, B, A, B, A, this string is generated by the given grammar. Okay, so I hope I have made the point clear. So this grammar will generate all, I am not writing, please, I am dictating, so please try to note it down. This grammar will generate all possible strings over A and B which ends with A. This grammar will generate all possible strings over A and B which ends with A. That's it. Okay, so I hope I have made the point clear to all of you. If you are not able to get all these things, please really don't worry. When I will show you construction of grammar, then you will get each and everything properly. Okay, so just wait for 2-3 lectures. I am going to start construction of grammar, and in that video you will get each and everything properly. Okay, so I hope I have made the point clear. So this grammar will generate all those strings over NB which ends with A. Okay, so next type of question can be, let me write it here. So a question can be A B A B A belongs to LG or not. This can be the question, yes or no, true or false. So just try to find that this string is generated by this grammar G or not. So you will easily say that yes, this string will be generated because it is ending with A. Okay, since I have told you the language, so according to language, all those strings will be generated by the grammar which ends with A. So since this string is ending with A, so this string will be obviously generated by the grammar. Please mind the word. Please mind the word. I am saying it again and again. String accepted by grammar. Please do not say like this. Say it properly. String generated by the grammar. So strings accepted by finite automata, or you can say NFA, DFA, and so on. String generated by grammar. These two rules you have to remember. Acceptors are used to accept the string, and grammar is used to generate the string. Okay, please try to remember all these things. Grammar is used to generate the strings. Generate the strings. Okay. Now let me move to next question. S implies AS, BS, or null. So what will be the language generated? See, I have already told AS, BS means what? Any number of A's and B's, we can mingle them up. And null means what? You will terminate it. Okay, and now let me tell you one more thing. What is null here? Null is what? A terminal symbol. See, S is, if I want to say that grammar is what? NTPS, na? NTPS, 4 tuple. So non-terminal will be what? S. Terminal will be AB. Please don't say null as terminal. No, null is not a terminal symbol. Production rule is all these 3 production rule will be copy pasted here, and S is your start symbol S. Now please don't say null as terminal. Null is what? Null is not a terminal symbol. Please remember this thing. Null is not a terminal symbol. Null is not a terminal symbol. So what exactly it is? It means absence of terminal symbol. absence of terminal symbol. Okay, if nothing is present, then it is shown as null. So null means what? Absence of terminal symbol. It is not a terminal symbol itself. It is showing that nothing is present. That means what? It is showing absence of terminal symbol. That's why its length was 0. Null string length is 0. You already know this thing. Okay, so please do not say that null is a terminal symbol. Okay, so terminal symbol here are only two, that is A and B. Now tell me language generated by this grammar. So smallest possible string is null. You have already guessed it right, that S implies null. The smallest is null. Now next, S implies AS and S goes to null. So single A is generated. Now S implies BS and S goes to null. So single B is accepted, and so on. Now you have already guessed that any possible strings over A and B can be generated by this grammar. So this grammar generate all possible strings over A and B. Please write it carefully. I'm not writing it, so I'm dictating. Please write it carefully. This grammar will generate all possible strings over A and B. That's it. No condition at all possible strings over and B. That means null, A, B, double A, double B, A, B, B, A, dot, 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 dot. So this will be a toy for you. Please try to play with it and try to generate strings. You will get your answer. Okay. Now let's move to the next slide. That is the last question of today's lecture. S implies AS, B and null. What is the LG? I'm repeating again and again. These are the type of question which came in exam repeatedly. So I am showing you just few examples, and if you are not able to get them, please do not worry about them. I will cover each and everything in detail when I will jump to the construction of grammar. Okay, when I will jump to construction of grammar, you will get each and everything properly. Okay, so LG, so smallest possible string will be null. S implies null, no? S implies null, so smallest possible string is null. Next is what? S implies ASB, and this S goes to null, so string next string will be AB. Next will be what? ASB, and this S will goes to ASB, na? AB. This A is copy pasted, this B is copy pasted, and this S goes to ASB. Now this S will go to null. So next string will be double A, double B. Similarly, you can guess next will be triple A, triple B, and so on. So LG will be A power n, B power n such that n is greater than equal to 0. That means what? Equal number of A's followed by equal number of B's. Please try to remember this thing. This grammar is generating all those strings over A and B in which we have equal number of A's followed by equal number of B's. Okay, why equal? So you can easily guess. Whenever we apply this production, na ASB, that means what? One A will increase and one B will increase. So each and every time this production rule is applied, one A and one B will increase in the string. That means what? That now equal number of A's followed by equal number of B's. So language will be A power n, B power n such that n is greater than equal to 0. And please try to remember all these things. That will this will make this may confuse you in exam. See, n should be greater than equal to 0. Why greater than equal to 0? Because when we apply n as 0, A power 0, B power 0, that will be nothing but null, and null is in our language generated by this grammar. Hence, n should be greater than equal to 0. Okay, so options in exam can be like this: LG A power n, B power n such that n is greater than 0. LG A power n, B power n is greater than or equal to 1. LG A power n, B power m such that n comma m greater than equal to 0, or LG A power n, B power m such that n is equal to m. Okay, so how many options are correct? A power n, B power n is greater than equal to 0. This is obviously correct. Let me use a different color. This is obviously correct. What about this? N should be strictly greater than 0. No, this option is wrong. Why this is wrong? Because this means what? Smallest possible string will be AB. So this language does not contain null, but null is present in our language generated by this grammar. Hence, this is wrong option. Similarly, this is also wrong because n greater than equal to 1 or n greater than 0. These are one and the same thing. These two are equivalent option. Please check it out yourself. Next, A power n, B power n comma m greater than equal to 0. This is wrong. Why this is wrong? Because see, no doubt null will be in the language. Null will be in this language, and null is present in our language also. But this language, in this language, n and m are not compared. That means A and B are not compared. So A can be greater than number of A's can be greater than number of B's. Number of B's can be greater than number of A's. So that means there is no comparison at all between them. But here we have comparison. That means A and B should be equal. So this is not the case. Okay, so just try, this is homework for you. Just try to write strings which are present in this language. Okay, which are present in this language and not generated by this grammar. Okay, it's, for example, I am writing double A B. This string is present in this language and it is not generated by this grammar. Similarly, try to write 4-5 strings which are present in this language but not generated by this grammar. This will open up your mind. Okay, now a power n, b power m, n is equal to m. Obviously, this is nothing but a power n, b power m only, and n is greater than equal to 0. See, here I am not saying about what about n and m, n and m are greater than equal to 0 and so on. So this is obvious part. Please remember this thing. This is obvious. Whenever we are writing n is equal to m and so on, so n and m are greater than equal to 0 only. Until and unless they have not specified it, please try to remember that by default we have to take greater than equal to 0 only, greater than or equal to 0 only. Okay, so n is equal to m, that is nothing but this is similar to this only. Okay, so this is also correct option. I hope I have made the point clear to all of you. If you are not able to get these things, I am repeating again and again. Do not worry. Please try to generate some strings. You will get the idea. This should be just like a toy for you. Okay. So all these examples which I have taught you, I have taught you 3 examples. Please try to generate. Keep on trying. Keep on generating strings and so on. You will get the idea. Similarly, here also keep on trying and keep on trying to generate string and so on. These all should be a toy for you. You should be able to do all these things and so on. Okay, so 3 example I have taught you. Really do not worry about all these things. If you are not able to, if you still not able to get after playing with all these things, after writing some strings and so on, if you are still not able to get, do not worry. I will cover each and everything in pretty much detail in the subsequent lectures. This is just the introductory part of grammar. Next topic will be Chomsky hierarchy. You will get some more idea about grammars, and next will be construction of grammar. In construction of grammar, you will be fluent in each and everything. Do not worry about all these things. Okay, thank you so much. This is all about this lecture. So we will meet soon in the next lecture. Bye bye.